Hello, ni hao, namaste. Myself Antarish Hengare and my thesis topic is Computational Conceptual Design, Architecture generated by Parametric Modeling, Simulation and Optimization. I hope all of you are very well. Let me proceed with my presentation. This research proposed a computational conceptual design approach to evaluate building performance and generate optimized design options. The presentation is divided into three parts. First is the background, second is the computational conceptual design, third is the implementation. Let me first start with the background. As we all know, the global energy situation is not stable and building consumes a lot of energy, which indirectly contributes to global CO2 emission. One of the most important reasons for this is energy consumption is sun. The sun is the savior, but it also creates problems regarding the comfort. From the right side graph, it is seen that space cooling and lighting consumes most amount of energy, and this mainly due to the sun's behavior. Solar radiation has great effect on the most comfort factors inside the building. So, solution for this problem is energy efficient design. It incorporates sustainable and efficient strategies while building the building, so the energy used at the time of building use phase is minimized. But most of the energy efficient designs cannot get optimal energy efficient design solutions, as several factors affect it at the same time. Hence, optimization methods should be used to get an optimal energy efficient design solution. Most of the architects are not familiar with this simulation optimization software, hence which leads to designer to choose a limited set of options. This optimization routine can be incorporated by using computational design and parametric modeling. The computational design is a process that utilizes computational capabilities by assisting designer in automating design procedures and tasks, managing large amount of data, simulation optimization, and generation of architecture. Hence, the problem identified is the conventional architecture practice involves rules of thumb and personal experience to guide design decision making. The conventional method relies on simulation model for the analysis of building performance of an already designed building. There is no optimization routine present in the conceptual design phase. The main aim of this research is to devise a methodology of computational conceptual design (CCD) and implement it using Grasshopper and Rhino 3D for generating optimized office building. And in the last, it will find the limitation and strength of CCD approach. The objective of this research is to devise early stage design approach and to use multi-objective optimization like genetic algorithm, and and to explore the case study office building by using computational conceptual design approach and find optimal design solution that addresses performance issues. And in the last, main objective is the finding the computational conceptual design is an effective approach in the direction of energy efficient design or not. So the key idea is combining computational design and building performance in the early stage of design. The integration can help more extensive exploration of design space towards an optimal solution which addresses performance issues. So why choose early stage of design? Patrick McLemie represented this graph. It shows designer has most capability to impact the design and cost of a project at the start of the project. So the traditional design method mostly focuses on the construction documentation, while the preferred design should focus more in the early stage of design. So this research mostly focuses on the early stage of design and especially to the conceptual design. So it is concluded from the background that from this study that the solar radiation is a very important factor concerning the comfort, and computational design and performance design combined together can be very helpful in designing a performance design. And if we combine them in developing at the conceptual stage, it can be very more helpful. and this can be done by using parametric modeling, simulation, and multi-object optimization. The following case studies has been carried out, and it pointed out that optimization process as a design approach in the early stages of design. Each case study is unique in its process and application, but all of them tries to solve the same kind of problem: how to generate a design solution. These case studies are selected based on the criteria specified as selection criteria. It is observed that performance-based optimization is successful and effective approach. The approach is very helpful to the architect in the early stages of design for decision making. All the case studies are related to energy efficiencies and daylighting except the third case study, and which is related to the wind and the structure of the building, and the fifth case study which is related to the radiation analysis. The third case study is taken as it deals with the wind performance of building and devises a method which is very useful for building shape optimization, which is not shown in other four case studies. The fifth case study is more related to the architecture element optimization by using radiation analysis. The other remaining three are more important to the building envelope optimization. This research, uh, there is a lot of research going on in this area, and most of the research is focused on some part of the building. Hence, it is very important to do the simulation considering the whole building, as this is challenge that should be overcome, and this research will focusing on the whole building shop optimization based on the radiation analysis. Why choose a Rhino grasshopper as a design tool? Rhino grasshopper is having many capabilities, and it is most important part of most two important things that I observe in this is the first is it's a free available software, and the forum of the software is very helpful. If you have any problem, any issues, you can write to their forum and they will reply very soon. Another strong potential of this software is the connectivity in between the grasshopper. So in grasshopper you get a different kind of plugins that you can interconnect with each other and make a parametric model that can address multiple performance issues. Like for in this research, I used the radiation. I connected the radiation, the geometry with the radiation analysis, and then to the Octopus engine, that is a multi-objective optimization. Octopus was originally made for multi-objective evolutionary optimization. It allows to search for the many goals at the same time. So this is my research logic map. The the literature study review from the literature study and the review from the exemplary study cases is used for forming a research framework, and this research framework finally helps me in the implementation. The part 2, computational conceptual design. The computational conceptual design, as the name suggests, there is two important things: computational, conceptual. So the computational, it uses whole environment of computation and it is applied to the conceptual stage. And what are the driving factors here? The evolutionary optimization and the building performance simulation. So all these combine together to form the conceptual design, computational conceptual design. Now many have many have the you may be thinking that how it is different from the performance based design. Why just not name it performance based design? While doing the research, I found out that the conceptual design has several phases. They are named as divergent, convergent, and the deepening phase. They follow each other, and in the divergent phase, for a particular design problem, an architect he have many solutions. Then he divides the one problem into many different solutions, and then he converges them into a few of them and shortlist them. Then again divide that few solutions into different again problems or different parts, and then again converges. And in this way, by using the divergent phase and the convergent phase one by one, the architect finds the final solution. He do this process manually, but when If we use an optimization engine, the optimization engine will help in doing this thing. So that if architect, if he do it by his intuitions, it is very hard, or he can't find every solution from that design space. But with the optimization engine, we can find every solution in that design space, and we can check how many solutions are there, and we can also know a different new solution, or we can explore a different solution from that space. So that concept of conceptual design, that same mechanism is used in this, and hence I have an idea that it should be named as computational conceptual design, as it uses the computational power in the conceptual stage, and the same and the optimization engine uses the same logic as used by the architect in the conceptual design stage. Now the general workflow, it is mainly divided into 4 phases. First is the parameterization, where you formulate the design problem and formulate the objective variables and constraints. Then you develop that parametric model, and then you integrate another models, performance model and simulation tools, and integrate the optimization algorithm with them together. The third part is the optimization, and the fourth part is the post-processing, that you identify the results and formulate the optimal design solution, and then do the finalizing the architectural things over the final solution. The software workflow goes in this way. You have the fixed parameters and a variable, you have the objective, three inputs, and you have problem. So you have constraint that has the fixed parameters, and variable that has the variable parameters. You connect them together and form the initial stage of building, initial model, and then you check, you put the analysis period and climate data, and do a radiation analysis and find the initial results. Now in this case, there are two kinds of objectives here. The first objective is to increase solar radiation in the heating period and decrease the solar radiation in the cooling period. So these are the two objectives that we need to achieve. And when we get the results from for every solution, the results are analyzed, and if the results meet the criteria that okay, this result is towards more optimum, then it is sent to the pool of optimized solution, or else it is cancelled and a new solution is derived from based on that solution. This research is implemented in generation of shape and form of a case study office building in 2 different cities with 2 opposite climates. First is the Tianjin, where I had my education, and the second is in Nagpur, where I am born, and that is my hometown. So Tianjin is a cold climate and Nagpur is a hot climate. Considering these as opposite climates, I choose these 2 sites because I want to prove that if you change the sites anywhere, this thing can be applied anywhere in the world, and you can find the different solutions depending on upon the climate situation of that place. So the part 3, the implementation. The implementation goes into the same 3 phases as discussed in the workflow. The site is chosen. It's a hypothetical choice site, and the site is 50 meter by 50 meter with all 4 sides, road on the all 4 sides, and it is facing south. There are 5 different variables. First is the base rotation angle, second is the top rotation angle, third is the fillet radius of the edges of the model of the building, and the fourth and fifth are the scaling units in the x and y direction. All the settings are kept to the center to form the base case model. This is the base case model. Now this is how we develop, this is a script for the base case model. These are the fixed parameters here. This is the variable 1, variable 2, variable 3, variable 4 and 5, and you finally get the final mass. This is the simulation script. For the simulation, radiation analysis is used from the Ladybug tool. Radiation analysis component is used from the Ladybug tool, and you can see there the results from the. You can see that there are two radiation analysis components. One is for the heating period, another one is for the cooling period. Because we have two objectives, so we have to do it in the two different types. And then total radiation for the heating period is calculated, and total radiation for cooling period is calculated based upon this analysis. This is for the base model performance in Thesis, and this is the base model performance in Nagpur. You can see it's more higher here heat radiation insolation. Now the Octopus tool. The Octopus tool is multi-objective optimization tool, and you can see here on the genome there are all genome connected. Genome is the component which you need to change, or it's a variable that you need to change to get the objective. So objective are connected here. I'm sorry. Then the second, now the difference between the case 1 and case 2 are the sites, and different sites have different analysis period. So for the analysis period of Thesis, it's from 1st to 13th of September. For the cooling period and heating period is from 1st to 13th October, as it is more cooling dominant. This is the simulation. This is a script for the simulation and optimization. Now once you click start here, the optimization will start, and it try to find all the solution in each space. There are about 200, population size is 100, and maximum generation are 20, so it will calculate around 2000 solution in one case. So these are the total solutions, and you can see difference between generation 0 and generation 19. The generation 0 is more random, generation 19 is more confined to its path. This is the results, finalized results, and selected options. Two are the extreme cases, one is the optimized. This is the extreme 1 case which is best for cooling, and this is extreme case 2, best for heating, and this is the optimized case for the engine. These are the values for the results, and the same process is applied for the optimization of the in the case of Nagpur. Just the two changes. The EPW file is changed to Nagpur, and another is the analysis period. This is how the optimization engine changes here, and the results can be seen. Every optimization is taking 8 seconds around. I'm sorry. So this is the optimized solution for the. Just comparing both the finalized optimized solution, you can see the engine is more oriented towards south. You see here it's more focusing towards the south, while the case 2 in Nagpur is trying to avoid the south side and more oriented towards the north, more area towards the north. These are the variable settings found in for the optimized cases, and this is the final solution after the post optimization process. I did the scaling of each glazing glass according to the incident solar radiation, and this is for the. You can see the engine is more open due to as it is from the cooling region, it needs to absorb more heat from the sun rays. This is Nagpur, it want to avoid more sunlight, and we already discussed the orientation. So conclusion is that research challenges the conventional design method and of conceptual design and provides a new methodology. The computational conceptual design is an effective approach, and it can generate the solution, and it also successfully demonstrated the ability to design a problem and provide design solution with optimum performance. And and there is a lot of research going on in this area. Most of the research is focused on some part of building, hence it is more important to do simulation considering the whole building, and this research focuses that issue. Now another important part is the difference between the conventional approach and the proposed approach. How it is changed, how it is different. The traditional way of designing a performance oriented design, it's more like a straight way, and when the design is developed, the performance is done, and if there is some changes, you design it again and you do the same thing. But in the proposed approach, you give a parameter to start the design parameterization, then you generate a design, and the performance simulation, evaluation and optimization, it goes on continuously by using the optimization engine till the final design solution is obtained. So the innovation point here is the computational conceptual design itself, and the use of any kind of this approach uses any kind of design irrespective of kind of building or climate. Then another part is whole building shape optimization using radiation analysis. This research focuses on the overall development of design through computation, and from the pre-designed calculation to the form generated, everything is done in a single model or in one environment. These are the references I used. Thank you so much. Have a good day.